Recording. Okay, so we'll talk about the VPC, right? And I explained VPC. Let me see if I have the draw.io diagram that I drew. If it is there, then hallelujah. What name did I even give it? Okay, great. So we'll just use this one, right? So I explained that VPC is an isolated, right, session or isolated section from the entire AWS cloud, right? So you have the AWS cloud, you have your region, right? So here our region is the US East one. Now within the region, so let's say yes, the whole North Virginia, there are a lot of people who are using the AWS cloud, but they can't leave their resources open like that, right? So they have to create a VPC to isolate themselves from the uh entire region, right? So they have so that's what we call the in the what's it called? In the traditional IT infrastructure, that's what we call the network, right? Now, if you are creating a network, then what you do is that so the entire network is the VPC, all right? And then under the network, you might have a range of IP addresses, right? And then the IP address, you are going to divide them into, you use CIDR to divide them, right? So if you are dividing them, then you are right? You are doing what we call what subnets. So they are just smaller sections of the entire network, right? So if you look at this diagram, we have a VPC with CIDR 16. I explained CIDR, right? Sheets.google.com, right? I'm just hoping that what we did the other time will still be here so that we'll use that. Great. So I explained that with you use previously IP addresses were in classes, right? So if you give, let's say, a class A IP address to one network, it means that the entire network is going to use that address. And then what the class full or the classes in IP address was doing was that one, you might end up giving a class of IP address to a network that might not be enough. Sometimes to you have to like it will be like an over provisioning of IP address, so it will be wasted. But with the classless, you can start from a class A and then even end up in a class C IP address. It means that you determine uh, how you want your network to be, right? There's no class, so it's just by the use of the CIDR. So that the CIDR is classless interdomain routing. So I explained that with this /16, I explained the whole concept of IP address, right? With each one being 8 bits, all right? So the four here, we call it octets, right? So octa is for 8, octa is 8, right? So we have 4 octets here. So if I write an IP address with a CIDR of 16, then it means that I've blocked the first 2 octets, and then these 2 octets can change. So that was when I made this, right, to show that here is blocked. So from here down to here are all blocked, okay, are all blocked. So in that sense, they don't change, all right? In that sense, from here, so this 1.0 are not going to change, but here can go from 0 up to what? 255 from here. And then we can have a lot of combinations, right? From uh, just these 16 bits. I think when we calculated, we were having around 64,000 plus. All right. So here we have, so 0 is part. So the total is actually 56 IP addresses. All right. Now, if we are demarcating this CIDR into smaller chunks of networks under the entire network, under the VPC, then that is where we look at what subnetting. So subnetting, I can decide that, okay, since I have about 32 bits of IP address, that's 64,000 plus, then I can divide them into smaller chunks. So maybe I can divide them into 256 IP addresses, right? So each network is going to have 256. Each network is going to have 256. And then per calculation that we did, if we do that, we might have 256 different subnets, right? If each of them should have 256 IP addresses, right? So the /24 also means that the first 3 octets will be blocked, and then only the last octet is going to change from 0 up to what? 255. But then this is the general understanding of it. But when you provision an IP address, AWS keeps what's it called? Keeps 5 of the IP addresses, right? And the popular one that I remember is one is for the network. So the first one is going to be for the network. Which network are we talking about? This time it is going to be what? The subnet. Okay. So here subnet is just a network under a small network under a bigger network. Right? That is just it. That is what subnet means. All right. It's just a smaller network under a bigger network. So it means that I can still go ahead and even divide this subnet into 2. All right, I can change this probably to like 26. So if I do 10.0.1, right, dots, let's say, so I'll look at up to some number and then block that. All right, so it means that the subnet is going to start, but those ones are complicated stuff when you get to the network administrating level, or if you want to, those who want to go into networking would get to understand this one better or appreciate this better, because we are going to work with IP addresses a lot. All right, so I can go ahead and then divide these ones into smaller chunks. So that is what we did here. We have the public subnet and we have the private subnet, and then we divided them. We just allocated just 256 IP address, right, by blocking the first 3 octets. All right, so it means that we still have more IP addresses left in this VPC. Okay, all right. So talking about subnet, we'll talk about subnet security, and then the security that works at the subnet level is what? The network access control list. So for network access control list, we know that they are what? They are stateless, right? And then the stateless means that by default, if you create a subnet, there is a default network access control list that is created for you, and then that one automatically allows all traffic by default, both inbound and then outbound. Now, if you would want to allow any traffic, right, inbound and outbound, then you will have to define allow rules. Okay, you have to define allow rules for all of them. Okay, so you have to define an allow rule for inbound, and then you define an allow rule for outbound. So let's say you want to allow HTTP address. Okay, you want to allow HTTP address, then you will have to allow on the network access control list, right? You have to allow HTTP inbound and allow HTTP outbound. Okay, and you can also talk about security groups. Now the security groups work at what? The instance level. So if you have allowed the traffic in the security group and still the traffic can't reach the instance, right, and it means that the problem is what? An access control list issue, because every traffic that is allowed by the NACL will, if allowed in a security group, automatically work. All right, but then if it is designed at the subnet level, because the traffic is going to hit the subnet, right? So if I allow HTTP, for example, if you have this security this instance here, and I allow HTTP address, HTTP traffic into the instance, but it is denied at the subnet level, since the traffic is going to get to the subnet before it gets to the instance, it will even be blocked at the subnet level. So the security group itself won't see that traffic. All right, the security group won't see that traffic at all because it is blocked at the subnet level. But when it is allowed at the subnet level and then it's allowed at the security group level, then you have a smooth operation. All right, And also, let's talk about route tables. Okay, now I explained that the fact that you name an instance, a subnet, public subnet, right, or private subnet, doesn't make them the private subnet. Okay, now to allow internet connectivity on your VPC, what you need to do is that you provision a NAT gateway, right? You provision a NAT gateway, an internet gateway, okay? You and then attach it to the VPC. Now your network has internet connectivity. So the next thing you need to do for you to make a subnet public, then you have to configure a route table to route what? Internet traffic. And then the internet traffic, public internet traffic is what? 0.0.0.0/0 to the internet gateway. So what this means is that you are saying that all public bound traffic should be routed to the internet gateway. Now, when you do this, when you define the route tables or the route in a route table, then you attach that to the public subnet. So this is where this drawing comes in, right? You attach it to the public subnet, or you attach it to the subnet that you want to make public. So if I attach that route table, so we use these different colors to differentiate between the route tables, right? So if I attach this route table to here, that is routing traffic to the internet gateway, it will make whatever subnet that this route table is associated with public. All right. Now, for private subnet, you don't actually define any other route. The default route is for local communication. All right. The default route is for local communication. So that one you see 1.0.0. So here for this route table, you have 1.0.0/16, and then the target will be what? Local. Okay. So that one you don't define any configurations, but you have an instance also in the private subnet, and then you would want it to have access to the internet, right? For maybe patch or upgrades or updates that they have to do. Then what you need to do is that you will provision a NAT gateway in the public subnet. So here you will have to do the route tables, and then you direct all public bound traffic to the NAT gateway. All right. Now you are putting the NAT gateway in the public subnet because the public subnet already has internet connection. So if the NAT gateway is in a public subnet, then it takes advantage of what? The internet connection that is available in the subnet, right? And then this route table is also attached to the private subnet. So if this route table is routing public bound traffic to the NAT gateway, then automatically it makes this private instance have access to the internet, but then for only outbound connections, right? So traffic cannot by default come from here into this subnet, all right, unless we specify security group rules to probably allow traffic that is coming from this instance security group. All right. But then traffic can move if the traffic. So if I request HTTP communication from this subnet, then that traffic can go and come back. All right. Now let me explain what I'm trying to say. All right. So in your private subnets, you have your instance. All right. And then you have an instance in the public subnet. All right. Now you need, so this instance would want to download maybe updates. So let's say probably it needs an HTTP, right? It needs HTTP traffic needs to travel from this instance outside, right? And then we said that it allows outbound traffic alone. So HTTP traffic is moving from here to here. Now, because it is this request was made from here, the traffic is outbound. And I explained that security groups are stateful. So it means that since this traffic left as HTTP outside, if it is coming as HTTP, right? If it is coming as HTTP, then it will be allowed inside without issues. That is how stateful security groups are. But for NACL, even if you leave as HTTP, when you are coming, NACL will check again that, okay, you are HTTP, but are you allowed? Okay, you are allowed. Come in. All right. But for here, for security group, immediately the traffic leaves and then it's coming back the same, then it will automatically be allowed. All right. So when you specify a NAT gateway for the security for for a private subnet and there's an instance there, you don't actually have to allow inbound traffic, right? Since the traffic is always going to move from here outside, if it has to return, it will return. As far as the origin was from the private subnet, so it goes and comes. That is the communication that is done. All right. So I've spoken about route tables. Why did I type security instance there? Security groups. And I've talked about NAT gateway. So yes, basically that's it about networking, all the networking concept, right? So NACL is stateless, security groups stateful. Okay, so subnet, you have private and public. All right. Okay, so somebody is asking for the order. The order myself I've forgotten. So let me see if I can. But what I know is that it reserves the first four. All right. Yes, the first one and the last one. Okay, no, let me check. I think somebody has sent to me. Yeah, so it reserves the first four and the last one. Okay, so the first four .0.0, so .0.1.2.3. That's the first four. All right, and then the last one. All right, so the first one is for the network, as I said. The second one is for the local router, the VPC router, and the third one is for DNS, right? The domain name system, and the fourth one is for future use or research. So it's like there's one always reserved in case, right? In case a new device is added, and then the last one is for the broadcast address. Okay. Uh-huh. And then I think they said the NAT gateway can also consume one. So that's the order. So the first four and then the last one. Okay, so yes, Alfred McPhilip, thank you. Yeah, so the 0.1.2.3 and the last one 255. All right. So as for, and then don't be confused with like how the 192.168 is just an example IP address, right? So the reason why I just mentioned the .0.1.2 because that one is always like that. So .0.1.2.3, you know, .255. Unless your address starts from, let's say, .10. So if you start from .10, then AWS is going to reserve dot 11, dot 12, right? Dot 13, dot 14, and then the dot 255. So you put that in mind. Okay. So that will be it on VPC and then networking. Unless anybody else has a question to ask, because that's basically the information that you need to. Unfortunately, we can't do the hands-on. Oh, VPC endpoints. The other time I explained. Oh, anyway, let me just talk about it again. So endpoints are what's it called? Interfaces or connection point that you use the VPCs. I mean, you attach to the VPCs, right? Or resources in the VPC to enable like connection. So, for example, you have DynamoDB, all right? DynamoDB or S3. You know, these ones are kind of are global services. When you are, even though you put them in a region, but they are accessible like globally, all right? So, if you want your resources to connect to an S3 bucket, right? Some a popular architecture will be this. Let me try and see if I can do something. All right. So you have, let me close this VPC small so that I will have space. Okay. So I'll put this one here. All right. So you have S3. Oh, I want a beautiful S3 bucket. Let me just use this one. All right. So you have an S3 bucket that sits outside your VPC. All right. So normally it's global. So when you are drawing it, it can even be outside the region. I can put it in the cloud itself. Okay. And then let me bring DynamoDB. Oh, I didn't want the 3D one. Mm-hmm. All right. So you have DynamoDB here, and you would want your instances to connect to the DynamoDB. So there are two types of endpoint. There's gateway endpoint and an interface endpoint. Okay. The gateway endpoint will be you deploy the gateway endpoint on the VPC. No, this API gateway. I want if I don't see it, I'll okay. So this is a VPN gateway. I would need this. Okay, so let's just use this. Let's just use it. This two. This is not the correct thing for. Uh, anyway, transit gateway. Let me use these two. All right, so this one will be for the interface. This one will be for the gateway endpoint. Okay, or let me try and search if I will see interface endpoint. Yeah. So I'll just use this. All right. So there are two endpoints. Now, if you are using a gateway, if you use a gateway endpoint, right, that one is attached to the VPC. So it will allow your resources to connect, okay? All right. And then from here, they can establish their connection to the S3 buckets. All right. This way. So if, and this one does not use internet connection, right? You use the local connection within the network. Okay. So you are not charged for this because the connection is not even via the internet, right? So that is the endpoint. Now, for interface endpoint, it uses internet bound connection. So you have to put it in the subnet. All right. You put the interface endpoint in the subnet, and then same way. So this one, I'll send this to the DynamoDB connection. All right. Or if it wants to connect to S3, okay, it can also do that. All right. So that is a tool. And so they are just connection points for your AWS services to connect to external services outside the VPC. Let me put it that way. And there are two VPC and the interface endpoint and then gateway endpoint. Any other question? You're welcome. Okay. So Agosi, are you here?
Yeah, I'm here.
Okay, great. So look at API gateway. Me, I don't understand API gateway. So Akosia is going to help us, right, with API gateway. So I'll stop sharing, then AK will share her screen with us. Hey, stop share. Right. And then she'll take us through API gateway. So Akosia, you can share your screen.
The host has to enable participant sharing.
There.
The host has to enable participant sharing.
Okay. Wait. Let me see. If I can do that. Okay.
Yeah,
I beg make Akosia co-host there, make she share in screen.
Akosia, let me hear your voice. Okay, Akosia said they said.
Akosia see yeah.
Okay.
But your Zoom settings every day they change. The other time they feel make like somebody co-host. And then they are not
Oh, sure. Okay, check like then I'll make you host. That'd be why.
okay. So on API,
Done.
okay, great. All right, so I can. So on API gateway, what we need to basically know is API gateway security, the endpoint, the features, all right, and what an API gateway is, what it does. Finish. That's basically what we need for the exam, and the integrations, right? The services that they are able to integrate. All right, so Akosia, you can Because are you talking? We cannot hear you.
Sorry, I be on mute.
Oh,
Okay, let me start over. Amazon API Gateway. The full meaning of API is Application Programming Interface. And with the help of APIs, your clients are able to access some functionality in your backend. So the API Gateway serves as a proxy between your clients and your backend services. When your clients make a request with an API, the API Gateway goes to the backend and returns a response to your client's request. Its API gateway is serverless and is managed. And some reasons for using API gateway include making your website or your web app more responsive and exposing certain services in the back end. There are 3 types of APIs supported in Amazon API Gateway. The first is the HTTP, which we use to expose your HTTP endpoints. They could be on-premise or they could be HTTP endpoints in AWS. And the WebSockets API, which is usually used for real-time. And the REST API, which could be public or private. So public is your resources that are publicly accessible. And then the private is the resources inside your VPC. The key features in API Gateway, the first is the methods. So it's some verbs that your clients can use to call a function in your backend. They include delete, get, post, put. And when you create a method in API Gateway automatically creates a resource-based permission so that anything that the API call has to perform an execution on, the API call has the necessary permissions to do that. And it also handles API versioning, where you can have multiple versions of an API call, and you can roll back to previous versions and keep track of your API versions. It's also used for handling different environments, like when you have the development environments, production environments, you can have them have different things that their API calls do. And it handles security too. So a very common reason why API Gateway is used is because of how secure and robust the authentication and authorization feature of API Gateways. And we'll have a look at that a bit later. And API Gateway also has the ability to cache API responses, thereby reducing the number of times your clients directly make calls to your resources. It also has a transformation. It can also validate and transform the requests coming through. So the requests coming, the API calls have to be in a certain format, and you define those rules. So if it's not in that format, API Gateway has a way to transform it to a format that it can work with. And there's also rate limiting. Here, you set a limit of the number of requests per second that a client can make. So if you set the limit to 500 and the client is trying to make more than that per second, it returns a 429 too many requests error. API Gateway integrations. The most common use of API Gateway, and then the easiest is when you use it to invoke a Lambda function. And you can also integrate it with your HTTP endpoints. And these endpoints could be on-premise or could be on AWS. And APIs of AWS services too. You can use API Gateway to expose the APIs of your AWS services. For example, you can have your clients directly load data into Kinesis data streams through API Gateway. And for VPC link to a route, for VPC link, that is when you want to expose private resources in your VPC. And there are 3 ways to deploy API gateway. The first is the edge optimized, which is the default way, and that is for global clients. It makes use of the CloudFront edge locations. The second is regional endpoints, where you are expecting your clients to access your API gateway from inside one region. And you can manually combine it with CloudFront if you want to extend to a few other regions. That helps you get more control over the distribution and then location settings. And you can also use it privately within your VPC using an interface VPC endpoints. Finally, for security, that's authentication through IAM rules, where if you have applications running on your AWS, your API gateway can attach the rules to your applications so they can perform some functionality on your other AWS resources. And if you have an if you have an identity provider, IDP, you can use Amazon Cognito for your authentication on API gateway. If you don't, you can use a custom authorizer where you use Lambda and to set your own logic about how you want your application to authorize users. And API gateway supports HTTP, but for extra security, if you want to use HTTPS with custom domain names, you have to use Amazon Certificates Manager. So if you're doing an edge optimized endpoint deployment, you would have to provision the certificates in the US East 1 region. If you're deploying a regional endpoint, you have to deploy your certificates in the same region as in the same region in which the API gateway sits in. And it's required for you to set up a CNAME or an alias record in Route 53 if you want to use the custom domain name HTTPS with Amazon Certificates Manager. Yeah, thank you. Please, any questions?
Very, very brief. Sana didn't point yet. Anyway, if anybody has a question, you can ask. I tell
It's
you,
nice to hear a new voice.
yeah,
The way
man.
they explain the thing, they enter my head. If you be Isaac, match my voice are too common. Then the brain they accept.
Yeah, so basically that's the information that we need to know about API. With this, you are good for the exam, like as far as API gateway is concerned. So,
Madam Akosia, if you don't want trouble, please share the slides.
Okay.
it is an important update. Okay. So please, any question? Oh, then there's a muhina motias here. Oh, nice.
Now do roll call to be Friday. Some people they bed. Start mentioning. Or let's end the call and reopen it again.
You mean like we could end the session?
Yeah. I think I was part of a learning group some time ago. People they join, sometimes 90 something. They're all sleeping. So at a point in time, the facilitator will be like, he's ending the session. We should use the same link to rejoin. We will come back, not 30 people will come back. The rest they don't go join again. That means they are asleep.
Okay, so I think the understanding is clear. So let me end the recording, then we'll do the roll